After implementing the genetic algorithm, I will build a track for the capsules, hope that they are able to learn how to drive around it, then realize that they are not, because that's too complicated to solve with genetic algorithm only. So I will need to look for new ideas. I saw in the last episode that the genetic algorithm is a proper way to teach the capsules how to get close to a target point on a canvas, and it was good to see that working, but I would like to take this to the next level. I go and build a track by simply putting a few extra walls on the canvas, and I want that the capsules learn how to drive around on that track. On the canvas, this is how the track looks like. The target point is still there from the last episode. Let's just give it a try, how the capsules handle these obstacles. I speed up the process, otherwise it would take too long. And the tricky part here is that even if they are geographically close to the target point, the wall is between them. So they still have a long way to go because they need to make some detour, but they are not aware of that. If I wanted to guide them to the target point, I would need to break down the process to smaller steps, to straight segments. First make them reach the first corner, then the second corner, and so on. And the idea behind completing a full circle would be something similar as well. After creating the walls, I create an array of so-called checklines, and the capsules will need to go ahead checkline by checkline. They always have to find the next checkline for extra fitness values, and the more lines they cross, the higher their fitness value will be. I set the layer properties to -2, so that the collision handling will be completely turned off for these checklines, and I set their color to something like pink so that they can be distinguished from the walls. Finally, I modify the starting point a little bit, which is a property of the population class. I delete the target point because I don't need it to be displayed in this scenario, and the environment is now set, and this is how it looks like. Just let me modify this right side because it's not looking pretty. So I just put an extra wall there, and I replace the put walls around method with 4 separate walls. That's it. But other than that, it seems to be fine. So basically the main change I'm about to make now will be modifying the fitness function. Instead of the distance from a target point, it will be based on the number of the crossed checklines. That would mean that every time a capsule crosses a checkline, it gets a reward, and its fitness value will heavily depend on that final amount of the rewards it got. First, let's try that one reward is worth 1 fitness value. In the Smart Caps class, I create a reward property starting at 0 and a reward method, which will contain a collision detection between the capsule itself and the upcoming checkline. If the reward is 0, it will check the collision with the first checkline. If it's 1, then with the second checkline, and so on. And every time that happens, the value of the reward property increases by 1. Then after the capsules stop and the setFitness method gets called, I simply set the fitness score to the value of the reward property, representing how many checklines did each capsule cross. And console.log everything out so that I can see if something goes wrong. I call this reward method in the game template at the end of this condition, so that the collision detection will happen in every iteration. And in the replace next gen method, I should set the reward property back to 0 so that it won't keep counting in the next generation. And I'd say let's try it, launching the capsules from their starting point, watching them having no idea what they're doing, and after they stop, the console displays their data, the fitness values, and the rewards for each capsule. Fitness value and reward are always the same at the moment, but spoiler alert, it won't stay like that forever. Actually, I just changed it right now. I will take the reward value to the 4th power, like I did in the previous episode. That will send a stronger message. And another thing I want to add is that instead of this console.log, the value of the reward property could be displayed real time. So on the very bottom of the game logic, after the balls moving condition, I iterate through the population and write the value of the reward property on their yellow-green head in white. And this div on the left side here that used to display the average distance from the target point, and theoretically still does, it needs to display the average fitness values instead. So the sum of the fitness values divided by the population size. and I make it a round number because that looks better. And now these values are supposed to increase as the capsule's brain develops, unlike the distance values before. So every time a new generation is launched, the average fitness value is supposed to be larger than in the previous generation. And the question is, how far can these capsules go on the track using this method? And it doesn't look bad. Now, the methods of the genetic algorithm are all the same as in the previous video. The only thing I changed here was the fitness function. There is actually an idea on how to make the crossover more effective as well. And that's, instead of having 50-50% chance for which parent to inherit from, the probability could be proportional to the values of the reward. For example, if one parent crossed 3 checklines and the other one only 1, then inheriting a step from the first parent would be 75%, and from the second one only 25%. That could further increase the chance of the fitter member of the population to spread its genes into the future. And this would be the way it's implemented in the crossover method. And before I launch the capsules one more time, I set the size of the brains to something larger to get a better idea of how far they can go. So I introduced the checklines, changed the fitness function of the capsules. The selection function remained the same. The probability for getting picked is linearly proportional to the fitness value, which is perfectly fine. And the mutation rate, I left it at 0.01. You can change it if you want, try it out if something else works better, but I didn't feel the need for that. And that's actually all I wanted to put in this episode. It's a little bit shorter one and serves as a transition episode between implementing the genetic algorithm and introducing the perceptron, which will be the building block of the upcoming neural network. And the neural network combined with the genetic algorithm that will give these capsules the superpower of being able to complete a whole circle or even 2 or 3. Because I think it looks obvious that they are now suffering a little bit, and it takes a lot of generations to find the right way, especially once they reach this trickier part, that combination in the middle. So yeah, genetic algorithm is done, neural network is yet to come. If you happen to be excited about that, then I'd say just keep watching.